Is it okay? Uh, Before starting my talk, uh, apology from the people who are working in this area. I am just considering the person who is very new in this field of research. I am starting just from scratch. Uh, can we write, for example, I take a set U, 1, 2, 3, 4, up to 10, and say subset A, 1, 2, 3. Can we write this set in the form of a function? My question is, can we write this set in terms of a function? Yes, of course, we can do. Of course, we can do. How we can define, for example, we can define, if we are considering this as a universal set, what actually we do, and we want to represent this set, we define a function from U to 0, 1 set. In this way, f of x in A is equal to 1 if x belongs to A, 0 otherwise. Now we have, now any subset of this U can be represented by this function. It means any subset can be represented by a function, and a particular type of function can represent a set. And you know, well-known name for this function is a characteristic function. Characteristic function. Characteristic function. This is our old set theory. This is our old traditional set theory. But what happens if we replace this set by interval 0, 1? Then it will become a fuzzy set. Now we have established a link between sets and functions, and then we have moved to fuzzy sets. And what is a fuzzy set? Fuzzy set is a function from a set to interval 0, 1. And what is the role of a fuzzy set? It actually gives grading to particular thing. For example, in ordinary set theory, we cannot say beautiful voice, just greater than 1, just less than 1. We can't say that. But in fuzzy set theory, we can apply certain gradings. We apply certain gradings, and certain gradings can be represented in fuzzy set theory. Is it okay? Then this fuzzy set theory has actually linked mathematics with the real life. Now, this is brief introduction to fuzzy set theory, and there are certain operations like union intersection, which are well known in set theory, are also available in fuzzy set theory. Then I move to another very basic idea of relations. What is a relation? If I have certain set A, then a relation is subset of A cross A. In general form, if you have two sets A and B, then A cross B. But for particular reasons, I am considering R is a relation on set A. And if this is a relation, then there are certain types of relations. And if a certain relation is has certain properties, then very nice applications in real life came into being. For example, if a set, if a relation is an equivalence relation, and as you know, what is an equivalence relation? Which is reflexive, symmetric, and transitive. Then what happens? It partitions a set into disjoint classes. Reflexive, what mean by reflexive? Anyone from last rows? What is a reflexive relation? If the element X belongs to A, implies that I am not going for exact definition. XX belongs to कोई भी कलर डाल. Okay. अच्छा. If XX belongs to R, for all X belongs to A, then this relation is called reflexive. And when it is symmetric, if XY belongs to R, implies YX belongs to R, where X and Y are coming from A, then we say that it is symmetric. And if XY belongs to YZ, and this implies always XZ belongs to R, then R is transitive. And if these three properties are here, then R becomes an equivalence relation. And what an equivalence relation does? It partitions a set into disjoint classes. For example, if I take a set A, 1, 2, 3, 4, 5, and I take a relation, say 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 1, 2, 2, 1, 3, 4, 4, 3, 4, 5, 5, 3, 5, 4, 3, 5. Please check, is it an equivalence relation? Is it reflexive? Okay, sure. It is reflexive. Is it symmetric? 1, 2, 2, 1, 3, 4, 4, 3, 4, 5, 5, 4, 3, 5, 5, 3. Nothing is missing here, I think. And is it transitive? Is this transitive? Now you can see. Now you can see 1 and 2 are in same class. 1 and 2 are in same class, and then 3, 4, 5 are in second class. Actually, this equivalence relation has divided the set A into two disjoint classes. In two disjoint classes. And you can see there is nothing common here. And when you take union of these two classes, and if there are some more classes, then union of these classes will actually become A. And it's very nice way which has applications in our real life. Student of class BS1 cannot be a student of class BS2. Okay. And very nice application. And this is actually a base for rough set theory as well. This is as well a base for rough set theory. Now, if you have idea of these things, then it will be very for technical part of my चलो इधर से कर लूंगा, अगर नहीं तो फिर मैं इधर से कर लूंगा. चलो लैपटॉप से कर लूंगा. ठीक है. What actually I am going to discuss here, concept of intuitionistic fuzzy sets and their knowledge measures. What is an intuitionistic fuzzy set? Basically, it is a generalization of fuzzy sets. And in following slides, you will know about intuitionistic fuzzy set just abstract information quantification. Why we are going in this talk? Information quantification is numerical form of any given data, is very useful in decision-making problems in Atlas of intuitionistic fuzzy sets, which are actually written as AIFS. Such quantification becomes more important due to uncertainties such as intuitionism and fuzziness. Distribution of these uncertainties is a key to determine knowledge associated with Atlas of intuitionistic fuzzy values. In this talk, first, distribution of above mentioned uncertainties and their relationships is discussed. Then knowledge measures are defined as a function of entropy and uncertainty index with certain desired properties. Existence of such knowledge measures has been established also in this talk. Uh, Introduction. A knowledge measure quantifies how well an Atlas of intuitionistic fuzzy set is defined. Study of knowledge measures for different types of fuzzy sets is an area of keen interest among the researchers, and there are reference to some papers. Entropy measures tells how much fuzzy is an intuitionistic fuzzy set. Initially, it was thought that both entropy and knowledge measures might behave as a dual of each other. If knowledge measure is increases when entropy decreases. When entropy increases, knowledge measure decreases. But later, Smith and his colleagues proposed that knowledge measure must depend on both entropy and uncertainty index. Therefore, they defined knowledge measures in such a way that it can it was dependent upon both entropy and uncertainty index. For a constant value of uncertainty index, it was expected that both entropy and knowledge measure would behave dual to each other. But on contrary, it was not the case. And according to some researchers, both entropy and knowledge measure are distinct quantities. Therefore, these must be treated independently. Therefore, an axiomatic approach was developed to define knowledge measures. On a close look, it becomes clear that axioms for defining knowledge measure in these papers are closely linked with certain types of entropy. Different knowledge measures have been defined for instance of intuitionistic fuzzy sets, and these are references where you can see these. All of these can differentiate only between a crisp set. Crisp set means ordinary set, and Atlas of intuitionistic fuzzy set. These knowledge measures do not have ability to distinguish between fuzzy sets and Atlas of intuitionistic fuzzy set. Basically, now we are dealing with the three types of sets: sets, fuzzy sets, and intuitionistic fuzzy sets. It is well known that uncertainty index in case of fuzzy sets is zero. Therefore, such knowledge measure will not produce reasonable results. In available literature on knowledge measures, almost all authors have the same viewpoint that when entropy or uncertainty index are decreasing, knowledge measure must be increasing, and vice versa, which means a knowledge measure must be a decreasing function of both entropy and uncertainty index. But according to best of our knowledge, no definition of knowledge measures available in the form of a genetic function of entropy and a generic function of entropy and uncertainty index. Aim of this talk is to show that knowledge measures should be defined by multivariable function depending on both entropy and uncertainty index and having certain desired properties. Moreover, to establish existence of such function. This is the aim of this paper. First we define, and then we show these actually exist. Now, first definition. Let X be a set, then an atlas of intuitionistic fuzzy set on A is defined in this way, where you can see we have these two functions, mu of Ax and gamma of Ax, from X to 0, 1 interval. These two functions are from the same set, and there is a certain condition you can see. Sum of this mu of Ax and gamma of Ax is less than equals to 1 for all x in X. These two functions, this is called membership degree or membership grade, and this is called non-membership grade. The example for such type of set, when you vote for a certain candidate, these are membership for that, and there are certain votes which are against that particular candidate, which are for non-membership grade. Is it okay? The values of mu of Ax and gamma of Ax indicate in the degree up to which element X satisfies and do not satisfy the property described by A respectively. If there is no confusion, then we denote intuitionistic fuzzy set by this pair instead of writing this way. We can write it in briefly in this way as well. And mathematics, people working in mathematics always abuse these notations. Another definition, let mu Ax and gamma Ax be atlas of intuitionistic fuzzy set on X, then this quantity, mu of Ax, pi of Ax is equal to 1 minus mu of Ax membership and non-membership when subtracted from 1. Look at this. And this always happens. This always happens. Is called degree of hesitation or uncertainty index and of the element X in X. And if this value is 0, then what happens? Then atlas of intuitionistic fuzzy set reduced to a fuzzy set. If there is no hesitation, then it is actually a fuzzy set. And an atlas of intuitionistic fuzzy value alpha, mu alpha, gamma alpha is an ordered pair such that these two are elements from 0, 1 interval with this condition. It is for actually for single element. Then we can say it is an atlas of intuitionistic value. The set of all atlas of intuitionistic values is denoted by this symbol in this paper, theta. Geometrically, this theta can be represented by the region bounded by this triangle, OAB. Is it clear? Here you have membership grades, and here you have non-membership grades. And all intuitionistic fuzzy values geometrically are bounded in this region. Any value from this region. Now we have established a link between geometry and intuitionistic fuzzy sets. Is it clear? There are at least two types of uncertainties associated with atlas of intuitionistic fuzzy set. One is related to intuitionism and is called uncertainty index, which I have already and the other is related with fuzziness, which is entropy. And this entropy is different from the entropy which is discussed in statistics. It is different from, but on the whole idea is the same. On the whole idea is the same, but these are two different things. Do not mix this entropy and entropy of statistics. Now, define a relation tilde on this set. This set, can I go back here? Okay. I am going to define certain types of classification on this area. And for classification, what I have to do? Already I am told I have to define certain equivalence relation. I have to define certain equivalence relation. And if I am able to define certain equivalence relation in this particular area, then I can classify this area. It can be divided into classes. Although it is, there are infinite many points in this area, but it can be classified if I have certain type of equivalence relation. And now I am going to define that. Define a relation tilde on that particular set of intuitionistic fuzzy values where alpha is related to beta if and only if their uncertainty index are same. If uncertainty indexes are same for two different intuitionistic values, then they are related. And I have to check whether this is an equivalence relation or not. Easily, it can be shown that it is reflexive, symmetric, and transitive relative. Definition is very clear. From here, it is very easily shown that it is an equivalence relation. And if it is an equivalence relation, what actually we have done? We have classified that triangle into these giant classes. Is it idea clear? Idea is clear? This means that classification of Atlas of intuitionistic fuzzy values is available with respect to uncertainty index. In this classification, all Atlas of intuitionistic fuzzy values with the same value of uncertainty index are members of the same class and denote such classes by this. It is a way to represent these classes. And that is, this set can be, if a certain value alpha is in a certain class, and it can be representative for the whole class. It is the same thing जब हम कहते हैं क्लास में आज जो हमारा CR है जाके क्लास को बता दो कि जी सर ने ये होमवर्क दे दिया है, तो क्या पूरी क्लास को बताना हमें जरूरी होता है? नो, CR को बता दिया जो रिप्रेजेंटेटिव है, इट मींस वो खुद ही बता देगा, इसका मतलब सबको पता चल गया। तो जब हम क्लासिफिकेशन करते हैं तो हम क्या करते हैं, हम सिर्फ और सिर्फ एक एलिमेंट ले लेते हैं और उससे पूरी क्लास जो होती है उसको रिप्रेजेंट कर देते हैं। पूरी क्लास को हम रिप्रेजेंट करने के लिए सिंगल एलिमेंट का इस्तेमाल कर रहे होते हैं, और वो कोई भी एलिमेंट हो सकता है। अच्छा, क्या जरूरी है कि CR को ही बताया जाए? कोई भी राह चलता हुआ स्टूडेंट मिल गया, टीचर का उस दिन मूड है कि जी मैंने आज इनको रगड़ा देना है, तो सरप्राइज क्विज है भाई आज। अब एक को बताया हो तो क्या क्लास ये क्लेम कर सकते कि सर आपने नहीं बताया था? नो, नहीं क्लेम कर सकते। तो पूरे का पूरा कोई भी एलिमेंट जो होता है किसी क्लास का, वो उसका रिप्रेजेंटेटिव बन सकता है। द सेम इज द आइडिया है, सेम इज द आइडिया है। Here, this is representing the class containing alpha. If there is some beta, you can replace this alpha by that beta particular. If there is some gamma, then you can replace that gamma by this alpha as well. No, this is you have seen this line. What actually these lines are? It can be seen that each class alpha pi is a straight line segment parallel to this line. This is the boundary which I told you in my first figures. And all the lines, the remaining line, and actually this line represents a class where uncertainty index is 1, where uncertainty index is, 0. Here is 0, 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 and then it is going on to increasing, and at this point it becomes 1. It becomes 1. It may be considered that these line segments have their initial point on mu axis, whereas the terminal points on gamma axis. We can go reverse as well. But for our understanding and for simplification of these results, we consider these points are initial points to represent these classes. The length of these line segments कितनी हो सकती है? यहां वाला जो है उसकी तो हो गई 0, तो जो मैक्सिमम है इसकी कितनी होगी? What will be the length of the last line? Square root of 2. Square root of 2. Very simple. Just apply Pythagoras formula and you will know the length of all these lines. But it's not important here. And I have shown some lines, some few lines where uncertainty index is 1, 0.8, 0.6, 0.4, 0.2, etc. Some of these lines. Otherwise, it is a continuous interval from 0 to 1. In general, any point of these line segments can represent the whole. This idea has been discussed already. As it has been seen, the line segment representing the class have same mu and gamma intercepts. Therefore, any initial or terminal point of the line segment can represent the whole class. Now, A0, where A is between 0 and 1, is the initial point of some class in this classification. Therefore, that can be represented in this way. The class containing this element. Instead of A0, you can also take 0A as well. They will represent the same class. Now, we come to the idea of entropy in entoshenistic fuzzy sets. As I have already mentioned, it is different from entropy discussed by Shannon in statistics. Different types of entropy definitions have been given and certain entropies have been defined as well. And I am going through some of these definitions which are already available in the literature. And this definition is taken from this paper. A function E from theta to 0, 1 may be called entropy measure if these three conditions are four conditions are met. E alpha is 0 when alpha is 1, 0 or 0, 1. Extreme points of first line. And entropy will be maximum when membership grade and non-membership grades are same. And entropy of the element and its complement. Complement means 1 minus. And this condition holds for entropy when these conditions are met. Okay. ये किसमें कंप्लीमेंट ऑफ दिस अल्फा वो जब रिवर्स करते होते हैं 1 माइनस और मेंबरशिप नॉन मेंबरशिप में कन्वर्ट करते ये वही है जो हमारे कंप्लीमेंट करते होते हैं यहाँ पे इंट्यूशनिस्टिक फजी सेट्स के लिए. हाँ, वो मेंबरशिप नॉन मेंबरशिप में बन जाती है और 1 माइनस हो जाता. अच्छा किया डॉक्टर साहब ने ये पूछ लिया कि क्या करते हैं हम मेंबरशिप को नॉन मेंबरशिप बनाते हैं, लेकिन कब बनाते हैं 1 माइनस करके, और जो नॉन मेंबरशिप होती है उसको रिप्लेस कर देते हैं 1 माइनस करके मेंबरशिप के साथ. An entropy measure ES for any X is defined in this paper, and its definition is this. Its definition in this paper is given by this equation, and when we plotted these apply this application, apply this definition to see what type of classification this definition gives in theta, we found that these lines can classify this area. And one particular thing you can see, if I extend this line from here to here, and if I extend this line from here to here, where they meet? 1, 1. They will meet, and all these lines meet at 1, 1. These are, and this is the classification of theta by entropy. This classification is by entropy. And in previous slides, what we have seen, classification by intuitionism, uncertainty index. Now we have linked these two different concepts here. And another type of entropy definition is also available in literature, and its classification is this. And same here, you can see we extend these lines from here, any line, these are lines meet here at this point 1, 1 again. These lines will meet again here at 1, 1. Then another definition, actually this definition is very popular, and mostly researchers use this definition. It is distance defined by Hamming distance. This definition comes from by Hamming distance. Normalized Hamming distance of two intuitionistic fuzzy sets A and B is in this way. Membership grades, difference of membership grades, and then non-membership grade, and then sum all these. And if there are n points, actually it is for a finite number of points. And of course, 1/2n for membership and non-membership grades. Now, entropy ESK of an intuitionistic fuzzy set is defined in this way: A over B, where A is the shortest normalized Hamming distance of X from either 1, 0 or 0, 1, from this point or this point, whichever is the shortest. If is in some point is here in upper half, then distance will be covered from taken from here. If it is in this way, then distance will be taken from this point. And if it is on this line, then you can choose any from anywhere. And B is the larger normalized Hamming distance of X from 1, 0 or 0, 1. From where it is smaller, from where it is larger. Now, we have defined classes with respect to uncertainty index, and we have defined classes with respect to entropy. Can we discuss behavior of elements when we are considering classification by uncertainty index? Behavior of entropy. Can we discuss behavior of entropy when we are considering classification by intuitionism, uncertainty index? And on the other hand, can we discuss behavior of entropy when we are considering classification with respect to intuitionism? Both ways, in both ways. Yes, we can discuss. We can discuss. In any class A0, entropy is lowest at point A0. Here, entropy will be lowest. And at the middle point here, it will be, and from A to 0 to middle point, it increases gradually. It will increase gradually. And then what happens? It will be maximum at this point. It will be maximum at this point. And then from this point to 0, A, when we move, it will gradually decrease from 1 to minimum in this particular class. Actually, the line, this line, with maximum entropy has divided the class into two equal parts. One is this, and one is, it has divided this line segment, this whole class, into two equal parts. Attach of intuitionistic fuzzy sets in these two parts, which are equidistant from this line, have the same value of entropy measure. Is it clear? And it is very clearly visible from the figure as well. Now, we go into the other way. Uncertainty index in class this. When E is taken from these entropies. Before discussing the behavior of uncertainty index in any general class, it is appropriate to study it in this class 00E. 00E, the line from starting from 0 to the line with the maximum value. And 10 First, in class 00E, uncertainty index attains all possible values from 1 to 0. At 00, uncertainty index is 1, which decreases gradually to 0 along the elements in the class from 00 to 0.5 to 0.5. At 0.5 and 0.5, actually it is middle point. Uncertainty index is 0 because 1 minus 0.5, 0.5 will become 0. When the class 10E is considered, it has only two elements. In this class, there are only two elements, 10 and 01. For these two elements, okay. We are going to finish. For these two elements, uncertainty index is 0. When any class with this is considered, it is represented by two segments with initial points on membership axis and the non-membership axis and terminal points on this line. Uncertainty index is maximum in these classes at these 2 points and then gradually decreases to 0 as we move along the line segment from initial points to terminal points. Now, stage has been set. Now we can plan. Knowledge measures. Different types of knowledge measures are there. Some knowledge measure, this knowledge measure has been given by Nagion in this way. And it is just definition is enough for. Then another definition, what properties should be in the knowledge measure? These properties should be in a knowledge measure. Particular this one. For fixed entropy, K alpha increases while phi alpha decreases. And in the other way, for fixed phi alpha, K alpha behaves dually to entropy measure. 1 minus alpha entropy, and this is hesitation. This is definition given by Smith for a knowledge measure. And you can see here 1 minus 0.5 entropy measure plus intuitionism. And from this, there is a proposition for this knowledge measure. You can see that the knowledge measure for all the elements are where membership grade and non-membership grades are equal. This measure, knowledge measure decrease just gives you membership or non-membership grade, nothing else. This is definition of knowledge measure given by in this paper. And here you can see number 2. What it says, it is just considering a particular case where just a 1.00. It is talking about just 1 point, nothing else. हालांकि there are so many other points. तो वहां पे सिर्फ उसका डिस्कशन हो रही है. तो ये इसमें भी प्रॉब्लम. This definition also has problem. These are observations in which we have noted for these, and these are basically drawbacks of these definitions which are already in the literature. You can quickly see these are some problems with these definitions which are already in literature. Now, this is first definition for knowledge measure. Let G be a function from 0, 1 to 0, 1. We are going to define just this function which have x, y is equal to 1. Either x is 0 or y is 0. G is decreasing in x when y is fixed. G is decreasing in y when x is fixed. And symmetry property is also there. Now, using this definition, we are going to define knowledge measure. A knowledge measure actually is a composition of these two functions, k from theta to 0, 1 cross 0, 1, and then g from this to 0, 1. And this composition is defined in this way. And if there is no ambiguity, instead of writing this, we just write it in this way. We just write it in this way. Again, abuse of symbols. And you can, this is for intuitionistic values, and this is for the whole atlas of intuitionistic fuzzy set. And from this area, you can see that this knowledge measure has ability to differentiate among crisp sets, fuzzy sets, and intuitionistic fuzzies. The required desired property which we want to have is available in this definition. And now the question is are there knowledge measures which satisfy these properties? Of course, these are there. This is the first knowledge measure which has this property, all these properties. Then this, when P is taking 1 or 2, actually at least 3 types of knowledge measures are available. Now, open problem is, can you define some other measures, knowledge measures, which satisfy these properties? It is an open question. At least 3 are here, and you can define many more. And this is the relationship between these knowledge measures. This is the relationship between these measures, and these are references which has been cited in this talk and paper as well. If somebody is interested, you can send me an email. I will send you this whole paper. Thank you very much.